This is Maya. Let's get into it. Your clinic automated its prior authorization process using an autonomous AI agent. The agent reads patient charts, queries a vector database containing thousands of payer medical policy PDFs, and submits approval packets directly to insurance portals. The execution logs look great. The agent processes hundreds of charts a day. Then, your prior authorization denial rate jumps by 34%. When your billing team investigates, they find a pattern. The AI agent is consistently citing an outdated medical necessity policy that was superseded by the payer 6 months ago. Welcome to Part 2 of High-Stakes AI, HealthTech and Clinical Operations. Today, we are breaking down the architecture behind the prior authorization phantom policy failure. Payer coverage guidelines change constantly. When engineering teams build naive retrieval-augmented generation over large PDF repositories, the system breaks in 3 distinct ways. First, temporal policy drift. Vector databases score text chunks based on semantic similarity or cosine distance. When an insurance carrier updates a policy, the old PDF often shares higher semantic overlap with the patient chart than the updated revision. Without hard temporal metadata filters, vector search surfaces deprecated guidelines simply because of high token similarity. Second, step therapy truncation. Fixed token chunking splits complex rules. A policy might state, coverage approved for drug B only if drug A has failed for 90 days. Standard chunking separates the prerequisite from the approval code, causing the model to hallucinate that the primary code was sufficient on its own. Third, stripped ingestion metadata. Raw PDF scrapers strip out publication timestamps, effective date windows, and state jurisdictions. The vector store treats a 2021 document with equal authority to a 2026 update. You cannot fix vector retrieval drift with system prompts. Instructing an LLM to always cite the most recent guideline is useless if the vector retriever returned chunks from an expired document. The model cannot reason over text that never reached its context window. To deploy prior authorization agents safely, retrieval must be governed at the infrastructure layer before context hits model memory. First, strict temporal version gating. Every document in the vector store must be tagged with mandatory, effective, and sunset date metadata. Retrieval queries must apply hard metadata filters to drop any document version not active on the date of service. Second, resolved dependency tree graphs. Instead of arbitrary chunking, parse payer policies into deterministic rule graphs where prerequisites, step therapy rules, and diagnostic codes are linked as non-fragmentable trees. Third, execution circuit breakers. If a chart requires prior authorization against an ambiguous or unversioned payer graph, the system must trip a circuit breaker and route the file to human clinical ops. At Claire by the Algorithm, we engineer stateful control towers that eliminate temporal retrieval drift, ensuring strict version gating and zero drift execution. Never let ungoverned RAG manage your clinical authorizations. Govern your enterprise AI at let'saskclaire.com. That is Part 2 of High Stakes Health Tech. Part 3 on ambient clinical scribes drops Friday. I am Maya. Thanks for listening.